Good morning, students. I am Professor Priya Sharma of EC Department, SIRT College, Bhopal. Anandam. So this is our lecture 15 of the lecture series Digital Circuit Systems subject, which we are going through nowadays. Lecture 15 will cover the BFSK and BPSK. BFSK stands for Binary Frequency Shift Keying and BPSK stands for Binary Phase Shift Keying. Coming to the binary frequency shift keying, it is also known as frequency shift keying is a frequency modulation scheme in which the digital information is transmitted through discrete frequency changes on the carrier wave. So this is the data signal which we have to transmit. This is the carrier signal. Carrier signal is the high frequency sinusoidal signal and this is the modulated signal. The data we send is known as the modulating signal. This is the carrier signal and this is the modulated signal. As you can see, the info signal which is at logic 1 or the signal at points which is present, the modulated signal will follow the carrier signal frequency, but at the absence of the signal or when it is at logic 0, the output or the modulated signal will be of a decreased frequency. Again, when there is a signal is present, it will follow the signal, it will follow the frequency of the carrier signal. Again, when it is absent, it will have a decreased frequency. So this is how we send the BFSK signal. It will contain, the modulated signal will contain two frequencies, f1 which is the same frequency as that of the carrier signal and f2 which is the decreased frequency due to the absence of the signal at that point. So we can write its equation as a cos 2 pi f1t when the signal is at binary 1 and a cos 2 pi f2t when the signal is at binary 0 level. So in BFSK, the 1 is called the mark frequency and the 0 is called the space frequency. So this is the mark frequency and this is the space frequency. And it is being written as as is the maximum frequency of the signal cos omega naught plus del omega t plus phi s. The total bandwidth of the FSK is given by twice of del f plus 2b, where b is the bit rate. This is the how BFSK is generated, and the binary data is passed to an on-off level encoder, and then it is multiplied, and an inverted signal is multiplied. It is multiplied with root 2 2 upon TB cos 2 pi f1t, that is the original signal, and here it is multiplied with the decreased frequency signal. Then both these signals are being added in the adder or a summer, and the final BFSK signal has been generated. These are the waveforms which was in the earlier slides also. Coming to the advantages and disadvantages of the BFSK. BFSK provides the advantages of FSK includes FSK provides better noise immunity. The signal transmission through FSK is quite simple. It is suitable for long distance data transmissions and bit error rate performance is also better than the amplitude shift keying. Disadvantages include it utilizes more bandwidth as compared to the other shift keying procedures. Bandwidth is not efficient. Detection of a signal at the receiver is very complex. The main features of FSK are it has high noise immunity, digital radio transmission in cellular telephone systems, application in modern modems for data transmission, likelihood of error less than amplitude shift keying modulation. Its applications are the technique is used in high frequency data transmission systems. It is extensively used in low speed modems. Now coming to the BPSK, that is binary phase shift keying. BPSK technique is the simplest among all the PSK techniques, all the phase shift keying techniques. In this, each signaling element is represented by a single data bit. Here, the carrier undergoes two phase reversals such as 0 degree and 180 degree. In phase shift keying, the digital bit sequence is first converted to non-return to zero bipolar signal, which directly modulates the carrier wave. This is called as a two-phase PSK or phase reversal keying. In this technique, the sine wave carrier takes two phase reversals such as 0 degree and 180 degree. Let us see the mathematical expressions for the same. Let us consider that the carrier wave is given as a cos 2 pi fct. The peak of the carrier wave is represented as A, where the load resistance is assumed to be 1 ohm as standard and the power dissipation is given by half of A square. So we can easily say that A is equals to root over 2p. A change in phase by 180 degrees notice with the corresponding change in the bit sequence. Assume the carrier for a symbol 1 will be given as root over 2 pi cos 2 pi fct, and for the symbol 0 it will be having a phase shift of pi. Again, pi represents the phase shift of 180 degree. Since cos pi plus phi is minus cos phi, thus signal S2 can be written as minus of root 2p cos 2 pi fct. Hence, the BPSK signal can be written as ST is equals to BT root over 2p cos 2 pi FCT, where BT will be plus 1 in case binary 1 is being transmitted, and it will be minus 1 in case binary 0 has been transmitted. This is the BPSK generation. First of all, as I have told earlier, that the binary data is being converted into a bipolar NRZ. NRZ stands for non-return to zero signal but through an encoder. Then this signal is mixed with the carrier signal in a balanced modulator, and we generate a BPSK signal. The BPSK generation includes the BPSK system consists of a NRZ encoder along with the product modulator and the carrier generator. The binary message signal is fed to the binary NRZ level encoder that converts the binary data input into equivalent bipolar NRZ sequence, that is empty, that is the message signal. This bipolar NRZ signal is fed to the balance modulator along with the carrier wave. Thus, the binary signal modulates the carrier wave that generates a phase shifted modulated signal termed as the binary phase shift keying signal. Here, as we can see that phase reversal when the bit sequence gets changed from either 1 to 0 or 0 to 1. When the bit sequence changes from 0 to 1, then we notice a positive phase change, whereas when the bit sequence changes from 1 to 0, then a negative change of phase is noticed. Now this is the waveform, how a BPSK signal is generated and how it looks like this is our binary data sequence or the message or the modulating signal. This is being converted to a bipolar non-return to zero sequence by just shifting the midline to the upper side. This is the cos wave or the sine wave, high sinusoidal wave used as a carrier wave. So we can see when the signal is present or at logic 1, it will follow the carrier signal. But as the signal changes from 1 to 0, there will be a phase reversal. You can see there will be a phase reversal. It is 180 degree out of phase. And then till the next changes in the state from 0 to 1, it will follow this phase change. As soon as it changes, it will again change the state from it will have a phase reversal. Then it will follow the same until the next logic changes from 1 to 0, and this continues, and this is how a BPSK signal has been generated. Advantages of PSK includes it allows more efficient transmission of radio frequency signals. Better noise immunity is noticed in case of BPSK technique. Less bandwidth is utilized by the BPSK signal in comparison to BFSK. Disadvantages include detection of BPSK signal is quite complex. Phase discontinuity sometimes leads to variations in amplitude of the signal. Applications used in the BPSK are used in phase modulation technique, in biometric operations, Bluetooth connectivity, wireless LANs, and in telemetry operations. That's all for BPSK and BFSK. I hope so it's very simple and it is clear for all of you. In case of any query, you can contact me. So all the best, very students. Work very hard. Thank you. Say Jananda.